Hello and welcome to this tutorial. We're going to talk about assigning IPv6 addresses dynamically. Now this is the second way to assign an IPv6 address. The first way is the static approach. And if you haven't yet watched that tutorial on static assignment, you should probably pause this video and watch that one first. Because in that tutorial, we cover something known as the EUI64 format. Well, that same thing is going to come up in this tutorial as well. So it's required knowledge. Okay, and so just like the static approach, there are two ways to use dynamic assignments. The first one is just using DHCP, and we use DHCP version 6. The second approach is using something known as stateless auto-configuration. Now, this second approach also uses DHCP. So before we continue into the details of both of these, let's get a little bit more familiar with DHCP version 6. Okay, DHCP version 6. Now there are two modes of operation, and by now you might have noticed a theme. That is, when we talked about static IPv6 assignments, there were two modes of operation. And now we're talking about dynamic IPv6 address assignment, and there are two modes of operation, both of which use DHCP version 6, and there are two modes of DHCP version 6. There are lots of twos here. Well, let's begin with the first mode. This is the stateful mode, and this one's pretty easy because it's basically the same as what we know from IP version 4. So a stateful DHCP version 6 server will give a device an IP address. It will also tell it the prefix length to use, in other words, what subnet it's in. It will also tell a device what the default gateway is, what the default router is that it should be using. And then finally, it will give it the IP address of the DNS servers that it should be using. So this is a stateful approach because the server is going to maintain that information. It's going to keep it and keep track of it. For instance, the IP address that it gave a device, there's a lease associated with it, and when that lease expires, the device could give it back or it could renew it. So a stateful server is mindful of all the information that it has given a device. Now on a side note, since we learned about how DHCP version 4 works, it's good to note that multicast is used in DHCP version 6 instead of broadcast. And quite simply, that's because IP version 6 does not support the broadcast message. Okay, so that's the stateful DHCP server. Now, the stateless mode of DHCP version 6 is really different than the stateful. So with the stateful approach, here we simply send a lot less information to the host. In fact, the stateless mode only supplies DNS server IP information. It doesn't assign an IP version 6 address, and it doesn't keep track or keep state of the information it delivered. So whereas the stateful server would keep track of what IPs it assigned, who it assigned it to, and how long they have it, well, the stateless approach doesn't even give out IP version 6 addresses, so there's nothing really to keep track of. It only really gives out the DNS server IP information that a host should be using. Okay, so when you think of the two methods, stateful is a lot more robust. Stateless is just very simple. Okay, so let's get back to the two dynamic methods of assigning IP version 6 addresses. And the first one is just to use a stateful DHCP version 6 server. So this approach is one that you already know because we just talked about a stateful DHCP 6 server, and it pretty much performs the same functions as an IP version 4 server. So although the specifics of the messaging in a stateful DHCP version 6 server differ quite a bit than version 4, we don't get into that level of detail in this tutorial. The operation is basically the same. So a DHCP server on this network would go ahead and assign an IP address to our desktop computer, also the prefix length. It would tell it which default router to use, and then obviously the IP addresses of the DNS servers that this host should be using. And that's it. It's really straightforward. Okay, now we move on to the second approach to dynamically assigning IP addresses, and this is known as the stateless auto-configuration approach. Now this method is a lot more complicated, but actually it results in us having to do less work. So basically here, we're going to let this device, this PC, pretty much determine its own IP address, and then we're just going to help it out a little bit by using a stateless DHCP version 6 server just to supply the DNS server IP information. So that's what stateless auto configuration is all about, and it's often referred to as SLAC. You might hear that term as well. So let's see how it works. First, the host is going to learn the prefix assigned to the network segment it's on. Okay, so it's going to actually determine its own /64 prefix that the subnet is already using. After it does that, the host is going to use the EUI64 format to complete the interface ID portion. And that's just like what we learned in the static approach. But here, we don't even have to tell or configure the prefix portion of the address on the computer. It'll do it all on its own. Now, you might be wondering, well, how does the host actually learn the prefix? Because we already know how EUI64 format works. Well, this is done by using something known as NDP, or Neighbor Discovery Protocol. Now, NDP works like this. There are two messages used by hosts and routers on a network segment, and these are a type of ICMP message. The first message is the router solicitation, or RS. And a host is going to send a router solicitation message to the multicast IP address FF022. And this multicast, by the way, represents all the routers on the subnet. Remember, again, we don't use broadcast anymore in IP version 6. So this host sends out the RS message, and that solicitation basically asks two questions of all the routers on the network segment. The first question is, what is the /64 prefix used on this subnet? And then it also asks, what is the default router, or what are the default routers, if there's more than one, on this segment? Okay, so those are the two key pieces of information that the host is going to ask for. Now, the routers on the subnet are going to respond with what is known as a router advertisement, or an RA message. The RA is also sent to a multicast IP. This one's a little bit different though. It's FF021. This multicast represents all the hosts on a network segment. You should get familiar with those two, FF022 and FF021. Now inside that router advertisement, it's going to list the /64 prefix used on that network segment, as well as all the default gateway routers. And so once the node receives that router advertisement, it learns the /64, so it learns its prefix, and then it uses the EUI64 format, and it determines the rest of its IP version 6 address, just like we already talked about. And so with this approach, we only have to use a stateless DHCP version 6 server just to supply the DNS server IP addresses. And then that completes the entire picture for this device, for this particular PC. So it has its IP address, it knows its default gateway, and it knows the IP addresses of the DNS servers that it should use to resolve names. So with this approach, it really is an auto configuration, and it's stateless because a DHCP server is just being used in the stateless mode just to supply just a minimal amount of DNS information. Okay, so that's the second approach. Okay, so let's summarize what we covered. We began with DHCP version 6, and there are two modes of operation. The first one is stateful, where the server sends a lot of information to the host, and it keeps track of some of that information. The second mode is stateless, where the server sends just a little bit of information, the IP addresses of the DNS servers, and that's it, and it doesn't keep track of any of that information. Okay, and then we talked about the two methods of dynamically assigning IP version 6 addresses. The first one is very simple. We just use a stateful DHCP version 6 server. So we assign all the information a host needs to get online, and we're done. The second approach is a bit more complicated, and this is the stateless auto configuration approach. Here, the host is going to determine its IP address all on its own, and it does this by using NDP. So it'll talk to the routers on the network segment, determine the prefix used, and also the default routers. It will then use the EUI64 format to complete its full IP version 6 address, and then at that point, All we have to do is use a stateless DHCP server in order to give it the IP addresses of the DNS servers, and then we're done, because it's determined everything else it needs, the IP address and the default gateways. Now all of this can, I think, get a little bit confusing because the words stateful and stateless come up in different areas. I would suggest segmenting it, thinking of DHCP just in terms of its two modes, and then the two approaches to using IPv6 dynamic assignments, the stateful and the stateless. Okay, so that's it. That is dynamic IPv6 address assignment. Thanks for watching.